Welcome to Unit 1, Lesson 4. Remember, our target is I can determine and create equivalent fractions. In Lesson 4, we're doing it by using a variety of strategies to compare fractions. In Video 1, I'm just going to look at two types of fractions that we're going to compare. Strategies for comparing fractions when they have a common denominator, and strategies for comparing fractions when they have a common numerator. Just a reminder, the numerator is the top number, digit I should say, or number actually, top value in your fraction. It tells how many you have. The denominator is your bottom of your fraction. It tells you how many pieces it takes to make a whole. The size of the pieces. It's the name of your fraction. Like if it was a 2, it would be halves. If it's a 4, it would be fourths. All right. So as we talk about comparing fractions, compare, remember, is telling us, is it less than, greater than, or equal to? One way to remember less than. 1 is less than 2. 2 is greater than 1. 3 is equal to 3. We remember equals pretty well. But less than, greater than, or equal to. For the most part, we're looking at are the fractions, which one is greater or less than the other. We've already talked about equivalent fractions. Now, the first is comparing fractions that have like denominators. All right. So an example, if we have 7/9 compared to 6/9. All right. So we're talking ninths. 7/9. So I'm going to partition my wholes into ninths. And when I draw my fraction bars, they're not perfect, so it's a little confusing, or a little, what's the word I'm looking for? Can't think of it. But I have 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9. Or misleading is the word I was looking for. 1/9, 2/9, 3/9, 4/9, 5/9, 6/9. Now, I can see 7/9 is greater than 6/9. Oh. So I'm going to use my greater than symbol. Now let's take a look at another one. Let's use 3/5 compared to 2/5. So as I draw my bars, both of them are getting broken into fifths. We have a common denominator. But we have 3/5 and 2/5. Well, in my bars, I can see 3/5 are greater than 2/5. I guess I shouldn't have done them both to be greater than. I should have done one less than. But, yeah, why don't we just do one more? Three sevenths compared to 4/7. So And now, to partition into 7 equal parts, I'm going to make 6 cuts. That's 2 parts, 3 parts, 4 parts, 5 parts, 6 parts, 7 parts. 1, 2, 3, 4, 5, 6, 7. Now, 3/7, 1, 2, 3, compared to 4/7. 1, 2, 3, 4. 3/7 is less than 4/7. Does anybody notice a pattern? Take a look at our 3 and see if you notice a pattern. Hopefully what you noticed is all you have to do is compare, when your denominators are the same, all you have to do is compare numerators. 7 is greater than 6, so having 7/9 is greater than having 6/9. The pieces are all the same size. Having more pieces is greater than having less pieces. If all the pieces are fifths, having 3 is greater than having 2 of them. If all the pieces are sevenths, having 3 is less than having 4 of them. All right, so whenever you have a common denominator to compare, all you have to do is to look at the numerators. If the numerator is greater than the other numerator, it's greater than. If the numerator is less than the other one, it's less than. And that's because the size of the pieces are the same. So the more pieces you have, the greater the size. So when denominators are the same, just compare numerators, and it is the same as your numerator. In fact, that is a good way to compare any fractions. If you set them to a common denominator and just look at your numerators, you will always know. All right, the next one that we're going to talk about in this is when they have the same numerator. Let's take, I thought this marker was working well. Let's take 2/3 compared to 2/5. So now they have the same numerator, but the denominators are different. 2/3 means to partition into 3 equal parts and take 2 of them. 2/5 means to take and partition into 5 equal parts. That's a 5 split, so a 2 split, 3 split, 4 split, 5 split, and shade in 2. And when I do that, I can see 2/3 is greater than 2/5. Let's do one more. Let's do 3/7 compared to 3/4. All right, so I'm gonna make my holes the same size. 3/7 means to partition into 7 equal parts, so 7 split it. That's a 2 split, 3 split, 4 split, 5 split, 6 split, 7 split. 1, 2, 3, 4, 5, 6 cuts, splits it into 1, 2, 3, 4, 5, 6, 7 pieces. And shade in 3. 3/4 means to 4 split it or cut it into 4 pieces. 2, 3, 4 split. And shade in 3. 1, 2, 3. So now my 3/7 are less than my 3/4. Take a look at our 2 equations and see if you notice a pattern. All right. What you should notice is when our numerators are the same, 2 is equal to 2, 3 is equal to 3, what we use to compare is our denominators. 3 is not greater than 5. 3 is less than 5, but the fraction is greater because these pieces are going to be bigger than these pieces. Think about it as something you really enjoy. If these were candy bars, if I cut it into 3 equal pieces, they're larger than cutting it into 5 equal pieces. Larger the denominator, or the smaller the denominator, the larger the pieces. The larger the denominator, the smaller the pieces. So when you're comparing using the denominator, you do the opposite of the number. 3 is less than 5, so 3 pieces are going to be greater than the size of 5 pieces. Cutting into 3 pieces is greater than 5. Same here. Since 7 is greater than 4, 7 pieces, cutting it into 7 pieces is going to make them smaller than cutting it into 4 pieces. So when your numerators are the same and you're comparing by denominators, use the larger denominator is going to be smaller pieces. So larger denominator is less than a smaller denominator number. Makes larger pieces. Bigger the number, smaller the pieces. Less the number, larger the pieces. Now, if you think back to earlier in the video, I talked about making a common denominator. Well, let's take a look at this. If I take 2/3 and I think, what can I make 3 and 5 both into? I think of my multiples of 3 and my multiples of 5, and the first one they have in common is 15. So if I take 2/3 and I multiply 2/3 by 1 in the form of the fraction 5/5, 2/3 would be equal to 10/15. And if I take 2/5 and multiply it by 1 in the form of the fraction 3/3, I get 6/15. And now, why don't I do that in the same color I did the last one? And now, if I compare same denominator, I'm going to use the numerators. 10 of the same size piece is greater than 6 of the same size piece. So again, 2/3 is greater than 2/5. When I made the sizes all the same size, pieces all the same size, I had to have a lot more pieces to make 2/3. But I don't need to do all that. I can just compare denominators. 3 is less than 5, so the pieces are greater than the size pieces for fifths. So in a quick review, when denominators are the same, use the numerator and go exactly what the numerator says. 10 is greater than 6, so 10/15 are greater than 6/15. When the numerators are the same, do the opposite of the size of the numbers. 3 is less than 5, so the size is greater. 2/3 are greater than having 2/5. All right. I will be making more videos on comparing fractions that do not have either common denominators or common numerators.